Module 3.2, simplifying expressions with rational exponent and radical. So the essential question, how can you write a radical expression with an expression with a rational exponent? So the answer is that you can write a radical expression as an expression with a rational exponent by extending the property of integer exponent on rational exponent. Right, so the next set of slides are just some examples. Okay, so if we look at our example A, it said that define rational and irrational numbers. A rational number is any number that can be written as the ratio of two numbers, A divided by B, where A and B are integers and B cannot be 0. An irrational number is a real number that is not rational. Right? And for B, we have a table, the sum of irrational and rational numbers. Okay? And then part C said that based on the result in the table, will the sum of two rational numbers sometimes, always, or never be a rational number? So the answer would be the sum of two rational numbers will always be a rational number. Right? And D, what about the sum of two irrational numbers? The sum of two irrational numbers will sometimes be a rational number. Right? And finally, the sum of a rational number and an irrational number. The sum of a rational number and an irrational number will never be a rational number. So F, now complete the following multiplication table. Similarly, it has both rational and irrational number. Okay, so let's go on to our next explain one. So as you have seen, to simplify expression containing radicals, you can rewrite the expression as powers with rational exponent. You can use property of exponents. You have already seen the power of a power property of exponents. There are additional property of exponent that are suggested by the following example. So we have 2 to the second power times 2 to the third power is equal to 2 to the fifth power. Okay, and the second example, we have 2 to the third power divided by 2 to the second. The answer would be 2 to the first power. And we have 2 times 3 raised to the second power. So the answer would be 2 to the third power times 3 to the second power. Right, so there's a mistake here, so let me fix this. This to be 2 to the second power times 2 to the second power. Oops, not 2, but 3. So let me change that again. Right, and then the third example, we have 2 divided by 3 raised to the second power is equal to 2 to the second power divided by 3 to the second power. And the last example is 2 to the third power raised to the second power will give us 2 to the sixth power. Okay, so the table will explain more. Right, so let's go through the first part. I'm skipping this because we learned this already in module 3.1. Right, so let's go through this part here. So it's called the product of powers property. So we have a to the m power times a to the n power, then it's equal to a n plus n. But notice that your base must be the same, right? So for example, if we have 3 to the 7th power times 3 to the second power, it will give us 3, 7 plus 2 will give us 3 to the 9th power. Okay? The second one is called the quotient of powers property. A to the n power divided by a to the n is equal to a to the m minus n, where a cannot be 0. Right? So an example for this could be, let's say, 5 to the 4 power divided by 5 to the second will be 5. 4 minus 2 will give us 5 to the second power. Right. The third property is called power of a product property. So if we have a quantity of a times b raised to the n power, then it's equal to a to the n times b to the n. So what I want you to think this part is that you need to distribute this n in. Right? So for example, we could have 4 times 7 raised to the second power. So this is 4 to the second times 7 to the second. So just bring the 2 in. Right? And the property number 4 is called power of a quotient property. So similar to property 3, we have a divided by b raised to n power. So it's equal to a to the n over b to the n. So then you need to distribute that n into every one of those. Right? So let's say, for example, we have 3 over 8 raised to the 4 power will give us 3 to the 4 power over 8 to the 4 power. Okay? And the last one is called power of a power property. So this is related to property 3 and 4. Right? So that means that you need to bring the n in. So then, for example, if we have 2 to the 4 power raised to the third, so this gives us 2 to the 4 times 3, so give us 2 to the 12 power. Right. So let me erase this so I can have a clear picture of the table. Right. Okay, so then let's go through some example. Right. So example 1, we have the cube root of the quantity of xy raised to the 9 power. Right. So then we have this. So we change that into 9 over 3, and 9 over 3 reduce to 3. Now we distribute the 3. Right. Okay. Or we can have this. So let's say. Right, so we have the cube root of x, y raised to the 9 power. So this is the same as xy, or the cube root the same as 1 over 3 times 9. So we reduce, that gives us xy raised to the third power. And then now you distribute this in. So it will be x to the third and y to the third. Right, and let's go into part B. So we have the fifth root of x times the square root of x. So the fifth root is the same as x to the power 1/5, and the square root is x to the power 1/2. Same, we have the same base, so we add the exponent. So x to the power 1/5 plus 1/2. So then, in order for us to add fraction, we need common denominator, right? So then for 5 and 2, the common denominator is 10. So 5 goes into 10 2 times, and 2 goes into 10 5 times. So then this gives us 7 over 10. Okay, so let's go on to the next one. So, okay, reflection. Why is the n root a not defined when n is even and a is less than 0? Well, remember, see that when a is less than 0, that means that a is a negative. So we have learned from our 3.1 is that if n is even and a is negative, then the power would be undefined, or we do not have a real answers. Okay, so let's go on to some example, right? So for example 5 and 6, simplify each expression. Assume all variables are positive. Okay, so then here, right? So here we said that we need to distribute these 2 in, right? So this gives us x to the 4 power, y to the second, and the cube root and the 4 they cancel out, so that gives us just y. Remember that there's a 1 here that we do that right, so this gives us x to the 4th power, y to the 3rd power. Okay. So let's go on to number 6. Okay, now I'm going to show you guys another way of doing 6. Right? Okay, if you look at 6, you can notice that they have the same index, right? So we can rewrite this as the 4th root of x to the 8th power over x to the 6th, and when we're dividing, we're subtracting, so a minus 6 is 4. So then this gives x squared. So then this becomes x2 over 4, so they give us x to the 1/2. Okay, so now let's go through some more examples. Okay, so over here we have a quantity of a x to the 9th power raised to the power 2 over 3. So then the example they show is that we distribute the 2 over 3 in, so then they cancel out the 3, so give us 2 to the 2nd power x to the 6, but 2 to the 2nd power can be changed into a 4, so your answer will be 4x to the 6th power. Right, and for part B, we distribute the 1/6 in, and we change 64 to the power of 2 to the 6th power. Okay, so let's do this step by step. Right, so we have 64 raised to the power 1/6, x 12 times 1/6. But 64 is 2 to the 6th power times 1 over 6, and x, or 12 times 1/6 can reduce, they give us 2, and this also can be reduced, they give us 2x squared. Right, and then for number 7, okay, so let's go through this step by steps. Right? Okay, notice that they have the power of -3, 2 over 3. Okay, so then we distribute this in, and we rewrite a as 2 to the 3rd power. So then the 3, they cancel out, right? And 9 times 2 over 3 reduced to -6. But when we have a negative exponent, so there's a step here, we can write 2 to the 2nd power times 1 over x to the 6th power. But 2 to the 2nd power is the same as 4. Right? So this gives us 1 over 4 x to the 6th. Okay. Right. Okay, so here are some more examples. Right. Okay, so let's do this step by step. Okay. So this is the way that your textbook show you. I'm gonna show you how to do this in a different way. Right. So let's start from here. So this gives us 1 to the power -1/2 over 4 to the -1/2 x 4 to -1/2. Right? And then also x 12 to -1/2. So all we did is we distribute the 1/2 in. Okay, so then we say that 1 to any power, the answer will be just 1. Okay, so this gives us, well, 4 is 2 squared, so this gives us 2 to -1, and x to the -2. And then also this part here will give us x to the -6. Okay. And so then when we have the 1 over 2 to the negative 1, x to the negative 2. Oops. Let me change this one so that we have x to the negative 6. Right? So when we're dividing, we're subtracting the exponent. So this gives us 1 over 2 to the negative 1, x negative 6 minus a negative 2. So that's become a positive, so x to the negative 4 over 2 to the negative 1. So then this becomes 2 over x to the 4 power, which is the same as that. Right. Okay, so I'm going to erase that. Okay, and let me show you another way how to do number 8. Right? Okay, well, let's try the reciprocal. Can notice that we have the power of 1/2, right? So I'm going to break this up. So this gives us 1, 4x to the 4 power raised to the negative 1/2, and x 12 raised to the negative 1/2. Right, and then we have the power is negative, so we can use the reciprocal. So this becomes 4x to the 4 power over 1. To 1/2, and we can do the same here. So this becomes x over x to the 12 power to the 1/2. Right, so when we use the reciprocal, we change the exponent into a positive. So in this, we will bring this in. So this gives us 2x to the 2nd power over, bring this in, so it gives us x to the 6th power. So this gives us 2x to the 4 power. Okay, so it's just the same as that. Right? Okay, so let's go on to number 9. Okay, so for number 9, the 2 is the power is a positive, right? Okay, so we can bring this into every one of these. Right? Okay, so then 9 is 3 squared. Right, so it gives us 3 squared, that gives us a 3. This is x to the 6th power times x to the 2nd power. And we can subtract that, so we have 1 over 3x to the 4 power. Right? Okay. And here are some more examples. Right. So when you see that the approximate number of calories C that an animal needs each day is given by C equal to 72 m raised to the power of 3 over 4, where m is the animal mass in kilogram. Example A, see that find the number of calories that a 225 kilogram bear needs each day. To solve this problem, evaluate the expression when m is 265. Okay, so then the formula they gave us that C equal to 72 m raised to the 3 over 4. So we substitute m for 365. Okay, so then this becomes the 4th root of 365 raised to the 3rd power. But 625 is the same as 5 to the 4 power. So then the 4 power and the 4 root, they cancel out. And which gives us 5 to the 3rd power, which is 125 times 72 give us 9,000. So we say that for a 225 kilogram bear need 9,000 calories each day. Okay. So here are some more examples, right? Okay. And then more. Okay. And the last one is on the example for geometry. We say that the formula for the surface area of a sphere in terms of its volume V, so S equal to 4 pi raised to the power 1/3 times 3V raised to the power 2/3. Okay. Right. Okay, so let's try this part. This is similar to what we did on 3.1. Right. So then rewrite 64 as 8 to the second power times to the 1/2. So then reduce or give us just 8. Right? Or we can write this as the square root of 64. So the answer is 8. So similarly to number 2, 100 raised to the power 1/2. So this is the square root of 100, or it's just 10. Right, a square root of 25, so things would be 5. And rewrite a as 2 to the third power, 4/3, so that's reduced to 2 to the 4th power, which gives us 16. And 128 is 2 to the 7th power times 3/7. That's cancelled, so it will be 2 to the power. The answer is 8. And so this is the same as 4 to the 4th power raised to 1/4. That's cancelled, so it will be just 4. And for number 7, a is 2 to the 3rd power times 1/3 plus 4 to the 2nd power half. They cancel out, so 2 plus 4 give us 6. And right, so there's this 5 to the 4th power raised to the power 1/4. 0 to any power is just a 0. So that's reduced, so the answer will be just 5. Right, so 3 to the 4th power raised to 1/4 minus 2 to the 4th power 1/4. They cancel, so 3 minus 2, so the answer is 1. Okay, so then that's the end of our notes for module 3.2.